Assalamu alaikum, welcome to my channel Mr. Mathematics Professional. So today we are going to talk about complex numbers. So complex numbers are such numbers which are of the form x plus iota y, where x and y both are real numbers. X and y both are belong to set of real numbers, while I, which is known as iota, and it has its own value, that is -1. It's an imaginary number. So I, which we known as iota, it's an imaginary number. So it's an imaginary number. So the value of iota is equal to 100 minus 1. So when we take square on iota, it is equal to -1. So now in every complex number there are two parts of the question. One is the real part and the second one is imaginary part. Like in x plus iota y, x is the real part of the question. This is the real part of the equation, while y is the imaginary part of the equation. This is the imaginary part of the equation. So in every complex number there are two parts. One is real part, one is imaginary part. The part which comes with the iota is usually known as the imaginary part of the complex number, while the part which does not have iota is known as the real part of the complex number. So now here is a simple question: is every real number a complex number? So the answer is yes. Every real number is a complex number with 0 as its imaginary part, like 1, 2, 3, 4, even 0. These are all are real numbers. So now 0 is a complex number. How? Because 0 has 0 plus 0 iota. This is its real part, this is its imaginary part. Similarly 1, if you write 1, so 1 is also a complex number because 1 plus 0 iota. So this is the imaginary part, this is the real part. So every real number is a complex number. So now we will study some operations on complex number. So the first one is a plus b iota is equal to c plus d iota. So if we said find the value of a, b, c and d, so it's very simple. This is the real part a and c, these both are the real parts, while b and d, these both are the imaginary part. So this implies that a is equal to c while b is equal to d. So it's the simple answer of that operation. So this is the first operation. The second one is, so we can add two complex numbers. For example, a plus b iota plus c plus d iota. So this is equal to, the real part will be added in the real part. This means a will be added in c and b will be added in d. So this is equal to a plus c plus iota we will take as common, b plus d. So a plus c plus b plus d. So now the third one is how we can multiply some number with the complex number, like k. If I multiply k into a plus b iota, so it's again simple. This is equal to ka plus kb iota. So this is the real part and this is the imaginary part. So now the fourth operation is how we can subtract two complex numbers, like a plus b iota minus c plus d iota. So it's again simple. We will subtract the real part from the real part and the imaginary part from the imaginary part. So this is equal to a minus c plus iota is take common, b minus d. So this is the operation of subtraction, that how we can subtract two complex numbers. Now the third one is sorry, the fifth one is how we will multiply the complex two complex number like a plus b iota into b plus d iota. So this is equal to, now a will be multiplied with a, this is equal to ab plus ad iota plus, sorry, sorry, this is c, this is c plus d iota. Okay, so now it's ac, the answer. Now look, just multiply a with c, this is equal to ac, real part with real part, then again real part with imaginary part, plus ad iota plus bc iota. Now plus the last one, bd iota square, because there are two iotas, one is this and the second one is this. So now it's equal to, it is equal to, now here we will combine the real part with the real part, like ac is the real part. Now the next one is, which one is the real part, we will see. So ac plus ad iota, it will remain same, again bc iota, it will again remain same, but now this expression will change because we have iota square value which is -1. Here the iota value is under root -1 while iota square value is -1. So we have the value of iota square, so we will use this value here, and that is plus, it is bd, and this is -1, so its value is -1. Now this is the real part, if we multiply minus with the plus, this is the real part, but it's in the minus value. This is equal to ac, which is the real part, minus bd, so the real parts are combined. Now the imaginary part is adi iota bc iota, so plus iota into ad plus bc. So this is the fifth operation of complex number. So this is very simple, so it's a simple operation. So now next is conjugate complex number. So what is conjugate complex number? So conjugate complex numbers are basically of the form a plus b iota and a minus b iota. So complex numbers of the form a plus b iota and a minus b iota, which have the same real parts like air and air, both a's are same, and whose imaginary parts differs in sign only. So the imaginary part, like this is plus and this is minus, so they have the same real part, the same imaginary part, but the imaginary parts are changed just by sign, their signs are different. So these type of these type of pairs of complex number are known as conjugate complex number. So thus, like 5 plus 4 iota and 5 minus 4 iota. Similarly, minus 2 plus 3 iota and minus 2 minus 3 iota. So these are two pairs of conjugate complex number. Now the modulus of complex number. So the modulus of complex number is basically, it's the distance from the origin of the point representing the complex numbers. Okay, like this is the Cartesian plane. There is some point where is this is a point where a is some value of x, so we will say it is x, and there is some value of y, so it's a pair, xy pair. So this distance from origin to the point, this is basically the modulus of complex number, which is equal to x square plus y square whole under root. So this is the modulus of complex number, and we usually denote modulus of complex number by z modulus. So z modulus is equal to x square plus y square whole under root. So this is the modulus of complex number. Sometimes we denote it by xy pair modulus. We can also denote it as by this sign. So this is the modulus of complex number. So what the modulus of complex number says? So it says if z is equal to x plus iota y, then z modulus will be equal to x square, then z modulus will be equal to x square plus y square. So this is what modulus of complex number is known for. Next is Fowler form of complex number. So Fowler form of complex number, again we have the Cartesian plane here. So we have, here is the point where x and y exist, and this is the modulus of complex number, which is x square plus y square whole under root, and here is some value of x, similarly here is some value of y. Okay, so this is theta. So the opposite side of theta will always be equal to r sine of theta, and the base will always be equal to r cos of theta. So when we are talking about Fowler form, so in Fowler form we always put x is equal to r cos of theta, y is equal to r sine of theta. Similarly, we will put r is equal to z modulus, which is equal to x square plus y square whole under root. So this is the Fowler form of the equation, and theta is equal to tan inverse of x over y. So this is so simple. Next is Demoiver's theorem. So Demoiver's theorem has its own proof. You can check its proof on Google. Here we will use the Demoiver's theorem result. So what Demoiver's theorem says? It says cos theta plus sin theta whole power n will be equal to cos n theta plus iota sine n theta for all n belong to set of integers. So this is the statement of Demoiver's theorem. So we will use this statement in complex number whenever we need something powers like cos theta plus sin theta whole power n. So now we have a question, and question is that find real and imaginary parts of x plus iota y whole power n for n is equal to plus minus 1, plus minus 2, plus minus 3, up to so on. So we will find this question's answer. So the solution is, so now let's solve this question. As we know that first we will change it into Fowler form. Our question is x plus iota y whole power n. So we are going to find the real part and the imaginary part. So in such type of question we will set as we know that x is equal to r cos of theta in Fowler form, and y is equal to r sine of theta. So and we know that r is equal to z modulus, which is equal to x square plus y square whole under root. Okay, now put the values of x and y in the above equation. So the value of x is equal to r cos of theta, and the value of y is r sine of theta, but we have iota here whole power n, which is equal to, we will take r as common, r into cos of theta plus iota sine of theta whole power n, which is equal to r power n into cos of theta plus iota sine of theta, which is equal to, now by using Demoiver's theorem we can write this equation as r power n cos n theta plus iota sine n theta. So we can write it as like that, because we know that the Demoiver's theorem says if cos theta plus sine theta whole power n is equal to cos n theta plus iota sine n theta. So we can write the left side of the equation in the form of the right side of the equation. So it's by Demoiver's theorem we solve this step. By Demoiver's theorem. So now next is this is equal to r power n cos n theta plus iota r power n sin n theta. Thus r power n cos n theta and r power n sin n theta are respectively the real and imaginary part of the equation. So now r power n cos n theta, because it does not have iota, so this is the real part of the equation, and r power n sin n theta is basically the imaginary part of the equation. So it's a simple where r is equal to x square plus y square whole under root, and theta is equal to tan inverse of x over y. So in this way we can solve such kinds of question which belong to complex numbers. Now the question is find real part and imaginary part. So we will solve by first we will change it into Fowler's form, then by solving we use the Demoiver's theorem, and at the last we get our real part and our imaginary part. So hope you like the video. If you like it, please subscribe to the channel. We will meet in the next video. Allah Hafiz.